So in 1950, as we all know, a revolutionary catastrophist model was unveiled by Immanuel Velikovsky in Worlds in Collision. This immediately encountered a hostile reception from the academic establishment, with attempts being made to get the publications of the book withdrawn. Not only did it challenge the prevailing uniformitarian paradigm by proposing that global catastrophes had occurred, but it placed them in the relatively recent past and maintained that the causes had been extraterrestrial, an almost unthinkable concept at that time. Furthermore, this was argued largely on the basis of myths and ancient writings. One scientist who was sympathetic towards Velikovsky was Albert Einstein. Although rejecting Velikovsky's proposed mechanism, which involved close encounters with Venus and other planets, Einstein was convinced by his arguments that there had been catastrophes of extraterrestrial origin. He emphasized to Velikovsky the importance of making correct predictions. These would not in themselves establish the validity of a scientific theory, but could play a significant part in the process. Velikovsky predicted that Jupiter would be found to emit radio waves, which was confirmed shortly afterwards. A few years later, a statement in Worlds in Collision that the surface of Venus was hot was also shown to be correct. Then Velikovsky's prediction that the Earth's magnetosphere extended into space was confirmed by the discovery of the Van Allen belts. None of these findings had been expected. During the 1960s, a number of other predictions by Velikovsky were confirmed, although others were not. Velikovsky had incorporated a range of theories within his complex scenario, so the fact that some of them were subsequently shown to be incorrect didn't mean that the rest could be discarded, or that because some of them turned out to be consistent with new evidence, the entire scenario must be valid. The correct predictions did, however, provide a requirement for Velikovsky's overall scenario to be given an objective examination, regardless of the unorthodox nature of its formulation, but that failed to occur. During the 1960s, the efforts of Alfred de Grazia, seen here with Velikovsky, in compiling a book called The Velikovsky Affair, documenting the unacceptable aspects of the reception given to Worlds in Collision, and also the inherent difficulties in trying to present an interdisciplinary hypothesis in the 20th century, played a significant part in the creation of a Velikovskian movement. A well-attended symposium on Velikovsky's theories was held in San Francisco in 1974, at which the astronomer Carl Sagan was Velikovsky's main adversary. Here are the two of them together. Aspects of Sagan's conduct were reprehensible, as acknowledged by conventional scientists, but these nevertheless maintained that, despite Sagan's lapses, Velikovsky's theories had been considered and shown to be unsustainable. As documented by de Grazia in another book, Cosmic Heretics, the San Francisco Symposium was a bifurcation point for the Velikovsky movement. The followers of Velikovsky, the Cosmic Heretics, may all have accepted the key position specified in the preface to Worlds in Collision, that there had been global catastrophes in historical times caused by extraterrestrial agents, but that still left plenty of scope for disagreement. Initially, the choice had seemed to be a straightforward one between the conventional view and Velikovsky's catastrophist scenario, with those opting for the latter generally accepting the full package as presented in Worlds in Collision. To Velikovskians and conventional scientists alike, therefore, the San Francisco debate was seen as a contest between two rival scenarios. Afterwards, it wasn't surprising that some cosmic heretics took Sagan's unfairness as justification for keeping their original beliefs intact. Others, however, began to consider the possibility that there might have been substance in at least some of the objections expressed. According to de Grazia, the most effective scientific criticisms of Velikovsky were to come from those who were sensitive to his work, with such criticisms coming as part of a creative process. Modifications to Velikovsky's scheme began to be suggested to eliminate aspects that seemed problematical, and eventually this led to the creation of alternative catastrophist models arising out of Velikovsky's original ideas. Our society, the SIS, was founded in 1974 to provide a forum for the Velikovsky debate. At SIS meetings and elsewhere, and in our review and in other journals such as Kronos, discussions took place about Velikovsky's ideas and the relative merits of the various modifications and alternatives being proposed. That process has continued to the present day. Let's consider a few topics. At the San Francisco Symposium, the first of Sagan's objections to Velikovsky's scenario was that Venus could not have been ejected from Jupiter as proposed, because there was no mechanism by which a body the size of Venus could have achieved the escape velocity necessary to break free from the giant planet. This has been cited as an example of Sagan's poor scholarship, because he considered the ejection of Venus from Jupiter in isolation, whereas Velikovsky maintained that the fission of Jupiter followed, although not immediately, from close encounters between Jupiter and Saturn, and then the assimilation by Jupiter of spread matter from Saturn. Since there could be an unlimited range of specifications for collisions of Saturnian debris with Jupiter, it must be supposed that some of them might have resulted in the ejection from Jupiter of an object like Venus. Escape velocity also featured in discussions of Velikovsky's theory that the object which became the planet Venus left Jupiter as a comet. Velikovsky wrote that dust and gravel fell on Egypt as the Earth moved into the tail of the comet at the time of the Exodus. Later, stones from the same source fell in the days of Joshua. It's now known that typical comets, much smaller than Venus, have two tails, one consisting of ionized gases, this tail always pointing directly away from the sun, and the other consisting of dust, gravel, and perhaps larger stones, this tail trailing behind the comet in its orbit, and normally appearing as the most spectacular of the two. The iron tail is the dark blue one at the bottom of this picture. A comet the size of Venus could still have an iron tail, but not one containing dust and larger solid material, because there's no mechanism which could generate the velocity necessary for solids to escape its gravitational constraints. Thus, the notion that Venus once had a cometary tail can't be excluded, but it wouldn't have been a particularly conspicuous one, and it couldn't have contained dust, gravel, and stones to deposit on the Earth. However, we can't entirely exclude the possibility that there was a cloud of dust, gravel, and stones following Venus, which may have looked like a cometary tail, even though it couldn't have been thrown out from the planet. In the Saturn theory, developed by David Talbot and colleagues from the initial ideas of Velikovsky, as we shall discuss later, Venus was no longer thought to have been ejected from Jupiter as a comet, nor to have been a newcomer to the solar system at the dawn of civilization. It was argued that the comet-like appearance of the planet, inferred from ancient writings and rock art images, was the result of the discharge of plasma streamers in a period much earlier than the time of Velikovsky's proposed Venus catastrophe in around 1500 BC. Another of Sagan's objections to Velikovsky's scenario was that, on the basis of conventional celestial mechanics, the odds were large, although not absolutely overwhelming, against the notion that Venus could have moved from a highly elongated orbit to its present almost circular one within a few thousand years. As to Velikovsky's claim that the transition could have been achieved by electrical or magnetic forces, no details had been given, so he was unable to assess the idea. On this occasion, Sagan's comments seem fair enough. In 1972, Ralph Jurgens attempted to reconcile the fact that planets and other bodies move within the solar system entirely in accord with Newtonian mechanics, as had been demonstrated by the successes of space missions, with Velikovsky's belief that the Sun and planets were electrically charged. Jurgens proposed that each planet was surrounded by a space-charged sheath, which would insulate the planet's electrical charge, so only on close approach, when the sheaths would be disrupted, would electrical interactions take place between the planets. That mechanism could not, however, help to explain how Venus had moved so quickly into a circular orbit. Wolf Thornhill, who played a major role in taking forward Velikovsky's concept of an electrical universe, acknowledged in 1999 that there were serious problems in explaining a rapid change in the orbit of Venus to its present one by the laws of physics as currently understood. He maintained, however, that because of the strength of the mythological evidence, it was time to re-examine those laws. Lawrence Dixon, who, of course, we don't need a slide for because he can, if anybody wants to know what he looks like, one can look at the real thing, demonstrated that, disregarding time scale, it would have been possible for Venus to have moved from an elongated orbit like this into its present one, following encounters with the Earth and Mars. However, assuming that the masses of the planets remain constant, and that energy and angular momentum had to be conserved, this could only have happened if the first contact had taken place when the Earth was in an orbit in which its average distance from the Sun was around half of what it is now. As currently understood, this would have put the Earth's position at the time well outside the habitable zone, where water could exist in liquid form at the surface of the planet. Neither human beings nor any other animal life could have existed under those conditions. Thus it seems that on the basis of current evidence and knowledge, an objective assessment of some of Velikovsky's theories relating to Venus suggests that they may not be impossible, but they appear improbable. On the other hand, it should not be overlooked that conventional ideas about Venus at the present time are far different from what they were when Velikovsky wrote Worlds in Collision, and, at least in general terms, have aspects in common with his vision. Venus, once regarded as the Earth's sister planet, has many anomalous features. For example, it's now acknowledged that the planet's surface is far hotter than previously realized. With an atmosphere much more dense and hostile to life than supposed, its rotation is retrograde, and its surface was molten relatively recently on a geological timescale. Estimates suggest that the surface solidified around 500 million years ago, but no actual dating studies have been carried out. It's now generally believed that the high surface temperature can be explained on the basis of a runaway greenhouse effect caused by gases known to be present in the planet's atmosphere, but that doesn't exclude other possibilities, and suggested explanations of other unexpected findings are more speculative. Work on understanding how Venus arrived at its present state has hardly begun. Turning from Venus to the Earth, one of the problems raised by Sagan was the lack of archaeological or geological evidence of a global catastrophe during the 15th century BC, or in archaeological terms, the end of the Middle Bronze Age. If the event had occurred as Velikovsky described, the evidence for it should have been easy to find. The close encounter between the Earth and the comet Venus produced violent electrical discharges, changes to the Earth's orbit and axis, resulting in a north-south and an east-west reversal. Also, streams of lava pouring from the interior of the Earth, major conflagrations and floods, meteorite showers, years of darkness due to atmospheric pollution by dust and hydrocarbons, and a widespread loss of life. Where, asked Sagan, was the scientific evidence for this scenario? Velikovsky's answer was that he'd provided abundant scientific evidence of major catastrophes in Earth in upheaval. Indeed, this was an impressive compilation of such evidence. However, Velikovsky didn't restrict himself to the two catastrophes he'd written about in Worlds in Collision, but also included evidence for earlier catastrophes. In many cases, Velikovsky gave no indication as to which catastrophe he associated with particular findings. And in some instances, his linkage of evidence to the Venus catastrophe was controversial. As for archaeology, he relied heavily on Claude Schaeffer, who claimed to have found evidence of catastrophic destructions at sites throughout the Middle East on several occasions during the Bronze Age. But this too was controversial. At our first Cambridge conference in 1993, John Bimson and Bob Porter, who's getting into the picture yet again, and as Barry said, it's a pity he's not here to amplify some of these points, gave assessments of Schaeffer's findings in the light of subsequent developments in archaeology. They agreed that there was strong evidence of widespread catastrophic destruction at the end of the early Bronze Age, but that for similar destructions at the end of the Middle Bronze Age, the time of the Venus catastrophe was much more tenuous. Although there was evidence of earthquake damage at many of the sites, there was nothing to indicate the kind of cosmic catastrophe envisaged by Velikovsky. Velikovsky had supposed that a geomagnetic reversal took place at the time of the Venus catastrophe, and such events were linked to inversions of the Earth by Peter Warlow, sadly no longer with us. Peter argued that the close approach of another planet could cause the Earth to behave like a tippy-top and either turn over completely or wobble and return to its original position without any change of rotation. The first situation could explain the reversals believed to have occurred at the time of the Exodus, and the second, the sun's anomalous movements reported in Joshua. Sagan had pointed out the impossibility of the Earth's rotation stopping and starting again in Joshua's time, which is what it took Velikovsky to be saying. But Peter argued that the tippy-top model provided a valid mechanism to explain the biblical passage within the framework of Velikovsky's scenario. Looking back, during our third Cambridge conference in 2007, Peter responded to criticisms which had been raised against his model. He insisted that it remained viable, and he believed that inversions of the Earth had taken place in the distant past. However, since there was no evidence of any geomagnetic event having occurred within the past 10,000 years, he now doubted whether any such inversions had taken place during that period. Velikovsky wrote that after the first Venus encounter, atmospheric dust prevented the growth of any vegetation for many years. However, living bristlecone pines have been found with more than 3,500 annual growth rings, apparently showing that they lived through this period. It's been argued that these hardy trees may have been able to shut down for a time until sunlight was once again able to penetrate through the atmosphere. Such behaviour is known to be possible for a year, but thought unlikely to be sustainable for much longer. In any case, growth would have had to be resumed with full vigour because there's no indication of a period when growth rings were unusually narrow. Tree rings in Irish oaks preserved in bogs, linked to ones in living trees by overlapping patterns of broad and narrow rings, similarly showed no indication of an environmental crisis during the 15th century BC. As with tree rings, layers in polar ice cores apparently provide a year-by-year record of climate and other environmental factors. Analysis of these layers has not revealed any significant change in climate during the 15th century BC, or any major anomaly involving atmospheric dust content during this period. Attempts have been made to reconcile this situation with the Velikovsky scenario, But counter-arguments have been raised against these, and whilst it cannot be said that either the ice core or the tree ring evidence has provided conclusive proof against the theory of a global catastrophe in the 15th century BC, it's evident that it's not offered any positive support. Is there positive support? According to Velikovsky, the close approach of Venus to the Earth stimulated extensive volcanic activity, and Laird Scranton, in his 2012 book, The Velikovsky Heresies, claimed to have found evidence to support this view, not only in relation to the Venus catastrophe, but also to the proposed Mars catastrophe around 700 BC. He reported that the list of large Holocene eruptions given on a website showed a record of widespread volcanic eruptions in both of these periods. On looking at the same website, I found that the large eruptions listed in the 400-year periods centred on the times of the Venus and Mars catastrophes were in line with what Scranton had claimed. To test whether the numbers were significantly high, I then compared them with the 400-year periods before, between, and after them. Unfortunately, the supposition that the numbers of large eruptions were exceptionally high in the two periods highlighted by Scranton can be seen to be unfounded. Velikovsky's book on the catastrophes preceding the Venus event was never published, but an extract appeared in Kronos in 1979. Velikovsky's study of mythology convinced him that there had once been a period when gods associated with the planet Saturn were preeminent. Velikovsky suggested that Saturn had then been much larger than it is today, and the Earth may have been its satellite. However, an encounter between Jupiter and Saturn caused the latter to become a nova and emit light for a period of time, losing much of its mass and also its hold on the Earth, under conditions which gave rise to the story of the deluge. David Talbot, seen here, Eduardo Cardona and F. Cochrane developed Velikovsky's ideas to formulate what became known as the Saturn theory. However, their studies of myths led them to conclusions which differed in some important respects from Velikovsky's. According to Talbot, it's now clear that Velikovsky was not correct on many details, but his best critics are those who have devoted their lives to investigating questions and possibilities arising from his work. They know that he was closer to the truth than his scientific critics. It seemed to Talbot and colleagues that at the dawn of civilization, most of the planets, including Venus, had been constrained in a cluster in the direction of the polar region, with Saturn being the most prominent of them. This led to the polar configuration hypothesis, which maintains that Jupiter, Saturn, Mars and Earth once orbited the Sun as a single linear unit, rotating about a point close to Saturn. Jupiter did not appear prominent from Earth, being largely hidden behind Saturn. This stable arrangement broke up at the end of what was remembered as the Golden Age on Earth, since it was followed by a time when Venus and Mars had various catastrophic interactions with us before the solar system settled into its present form. The first major discussion of the Saturn theory in Britain took place at our Silver Jubilee celebration in 1999. At this conference, Cochrane outlined evidence supporting the theory, but acknowledged the most obvious objection to the Saturn theory is its apparent incompatibility with conventional astrophysics. This is indeed a formidable objection, one deserving of serious attention and ultimately a valid answer. Ideally, in terms of offering a viable physical model for the polar configuration. An early attempt at such a model was shown to be untenable. Later, Emilio Spedicato developed a model in which the polar configuration could hold together, but only for a short time. This model didn't take into account tidal effects or electromagnetic forces, which offered some hope to the supporters of the Saturn theory, but the formulation of a viable physical model is still awaited. Speaking after Cochrane at the conference, Peter James said that the most obvious problem with the Saturn theory was how to explain how the Earth and its inhabitants could possibly have survived the upheaval of being wrenched from a position which was always close to Saturn and hurled into an independent orbit around the Sun. James suggested that the apparent description of Saturn in ancient writings as a brilliant object could be explained if a large body had crashed into Saturn at that time and turned the planet into an incandescent ball of vapour, out of which Saturn's rings were eventually formed. Another challenge to the Saturn theory, and indeed planetary catastrophism in general, has been posed by patterns of temperature fluctuations inferred from both ice cores and deep-sea sedimentation cores, and also sea level data from coral terraces. These are generally consistent with predicted Milankovitch cycles derived on the basis of the Earth's current orbit. These don't provide a complete explanation for temperature change because there were occasions when the records show dramatic disruptions, but the existence of underlying patterns of temperature fluctuations in line with predictions suggests that the Earth has been in its present orbit for a very long time. This issue can't be ignored. In 1997, Talbot teamed up with Thornhill to begin arguing that several of the regular motifs found in mythological inscriptions and rock art are depictions of plasma discharge streamers between planets. Tony Peratt, a recognised authority on plasma discharge formations, acknowledged that the same patterns are regularly found in laboratory experiments. Rens van der Sluis has made a particular study of the axis mundi, now regarded as the imaginary extension of the axis of rotation of the Earth, but which, on the basis of mythology and rock art, seems to have been clearly visible around the end of the Neolithic period. In the polar configuration scenario, that could have been due to electrical discharges along the axis between the Earth and the other planets, but other explanations are possible. Peratt has shown that an aurora could take the form of an enormous column if the solar wind was 1 or 2 orders of magnitude greater than it is now. So the ancients may have witnessed a long-lasting, high-energy auroral storm. During the past 20 years, there have been tremendous advances in our knowledge of the universe. The Hubble Space Telescope and other sensitive instruments revealing features that were totally unexpected, including immense clouds and streamers of hot ionized gas. Conventional scientists attempt to explain the emerging picture in terms of concepts such as black holes, dark matter and dark energy, but accept that there are currently many aspects of the universe that they don't understand. Similar considerations also apply to investigations of subatomic particles. Amongst the heretics, much work has been carried out by Thornhill and Talbot in developing unorthodox ideas about the nature of the universe and challenging the conventional gravity-dominated view of celestial mechanics. A view of cosmic catastrophism which followed Velikovsky's approach of taking ancient myths as indications of real events, but remained consistent with the conventional view of celestial mechanics, has been proposed by Victor Klube, seen here, and Bill Napier. Estimates of the range of diameters of cometary nuclei in the region beyond Jupiter suggested that some could be as large as 200 kilometers. Although small by planetary standards, a comet of this size could pose a very serious threat to Earth if propelled into the inner solar system. Even if there was no direct collision with the Earth, the giant nucleus could well disintegrate under the gravitational influence of the Sun, releasing large amounts of dust and boulders to cause significant problems for life on Earth. Klube and Napier have argued that the present orbits of Comet Encke, the Taurid meteor stream, and several asteroids indicate that they were all part of the nucleus of a giant comet 20,000 years ago. This comet, Proto-Encke, came into the inner solar system and began to disintegrate. The glacial conditions of the late Pleistocene resulted from the dusting of the Earth's atmosphere by some of the breakdown products. This eventually cleared, but Klube and Napier suggested that the Earth encountered more remnants of the giant comet around 2300 BC and later at the time of the Exodus. In periods during the early and middle Bronze Age, Comet Encke would have appeared as a brilliant object in the morning and evening sky. Some myths and legends arising from catastrophes during this period may subsequently have been transferred to deities associated with the planet Venus, which would have been the brightest object in the morning and evening skies after Comet Encke dimmed following further disintegration. As for events before this time, van der Sluis has suggested that the disintegration of Proto-Encke could provide a possible cause of the huge auroral storm of the late Neolithic. However, questions have been asked about how the Klube-Napier theory can explain details of ancient art and literature. Now let's attempt some conclusions. First, let me make the obvious but important point that none of us would be here today had it not been for the pioneering work of Velikovsky. Secondly, let me say that I stand shoulder to shoulder, or perhaps I should say sit shoulder to shoulder, with de Grazia regarding the stance he took on the scientific reception system in the Velikovsky affair. As de Grazia pointed out, the peer review system operating in each specialist area works perfectly well in the majority of cases, but it cannot cope with interdisciplinary research, which is where the majority of major breakthroughs are likely to take place, being the product of truly original thinking. That applies not only to the work of an individual like Velikovsky, but also to interdisciplinary projects involving teams of specialists from different subject areas. Ways need to be found to resolve these issues. I also believe it to be very likely that catastrophes of an extraterrestrial origin have had a significant effect on Earth in the geologically recent past. Unlike the situation in 1950, it's now accepted, in principle, that mechanisms exist which could give rise to such catastrophes. So, for example, it's been established that the threat from asteroids and comets is far greater than had been supposed because they explode with great power on impact. Nevertheless, when it comes to investigating any particular episode of apparently rapid change, there's a clear reluctance to take seriously the possibility that it might have been caused by a natural catastrophe. Some beliefs from the past have become so firmly embedded into the culture of scholars that they persist long after any justification for them has disappeared. One of these is the supposition, established in the 19th century, that uniformitarianism is in some way more scientific than catastrophism. And another is the belief that only superstitious common folk fear a threat from the skies, long accepted by scholars on the authority of Aristotle and Newton. Even after it became clear that mass extinctions of species had occurred on several occasions, it was generally supposed that each must have taken place over a substantial period of time as a result of slow climate change, perhaps linked to continental drift. Challenging this view in 1980, Luis and Walter Alvarez argued that the extinction of the dinosaurs and many other species at the end of the Cretaceous period had been caused by the impact of a large asteroid, and they produced evidence to support their case. However, most geologists continue to suggest that an impact hypothesis was somehow unscholarly. During the 1990s, it became established that a 10-kilometre cosmic object had struck the Earth near Chicxulub in the Yucatan at the end of the Cretaceous period, producing an enormous crater 180 kilometres in diameter. This indicated an explosive force equivalent to around 100 million megatons of TNT, 6 billion times that of the Hiroshima bomb. Even so, many maintained that the dinosaurs were well on the way to extinction anyway, so this impact just made a small contribution to the process. Similar attitudes have been shown over the past few years concerning investigations of the theory put forward by Rick Firestone and his colleagues. This followed on from a suggestion made in 1976 by Hans Kloosterman. It was proposed that a cometary catastrophe at the end of a relatively warm period, around 12,900 years ago, caused the extinction of Columbian mammoths and other American large animals, as well as a return to extremely cold conditions in the Younger Dryas, the final stage of the Pleistocene epoch. Much geological evidence of a significant extraterrestrial impact has been produced, but it's generally been dismissed by others, and sometimes even the finders of such evidence have sought an alternative explanation. For example, Annelies von Herschel and colleagues recently found nanodiamonds, a known product of impacts, at the Uselo horizon in Holland, generally believed to mark the beginning of the Younger Dryas. This boundary is characterized by a carbon layer, the product of wildfires, which frequently follow an impact. However, the Dutch team concluded that the nanodiamonds had probably been formed by the wildfires, even though there's no known mechanism by which this could happen. Napier has suggested that the event was caused by debris from the disintegrating giant comet, Proto-Encke. After that, in his scenario, the return to warmer conditions at the end of the Younger Dryas, around 11,500 years ago, came when cometary dust began to clear from the Earth's atmosphere. However, according to Greenland ice core data, average temperatures rose at this time by almost 10 degrees C in a few years, which might indicate a more specific event. In 1990, Spedicato linked the climate change to an oceanic impact, and more recently to a close encounter with a planetary-sized body, as did Derek Allen and Bernard Delaire. Flavio Barbiero suggested that a rapid pole shift had taken place at this time, caused by an asteroid impact. Earlier this year, Robert Schoch argued that only something akin to a major plasma event, resulting from emissions from the Sun or other cosmic body, could explain the rapid rise in temperature which occurred at the end of the Younger Dryas. It's now generally believed that the melting of polar ice as a result of this climate change raised sea levels by around 100 metres. Although inhabitants of low-lying coastal regions would generally have been able to retreat to higher ground before their villages were submerged, the sudden collapse of natural barriers holding back the advancing waters must occasionally have led to catastrophic flooding, possibly giving rise to legends of a universal deluge. Velikovsky's proposed mechanism for the universal deluge was the transfer of water from the atmosphere of Saturn between 5,000 and 10,000 years ago. Whatever the mechanism, there were undoubtedly catastrophic floods during this period. Moving forward, Lonnie Thompson has assembled evidence from around the world of an abrupt climate change at approximately 3,200 BC, which was coincident with structural changes in emerging civilizations. Tropical plants were covered by an ice cap in the Peruvian Andes at this time, and the Sahara region switched from grassland to a barren desert. Thomson attributed the climate change to a dramatic fluctuation in solar output. Alexander Tolman had previously proposed an impact event at around 3150 BC. More recently, it's been claimed that Sumerian astronomers in 3123 BC recorded the passage of a fireball across the sky. That's controversial, but there are clear indications of a climate change at around this time, although the rate of change is a matter of argument. Clear indications of climate change coincident with the collapse of civilizations are also found at the end of the early Bronze Age, dated to around 2300 BC by conventional scholars and also by Velikovsky. This was the period of Velikovsky's proposed event associated with Jupiter of the Thunderbolt, when the old kingdom of Egypt fell and Sodom and Gomorrah were destroyed by fire from above. Mo Mandelker compiled a wealth of evidence of catastrophic events and rapid climate change at this time, presented in a series of papers in our journals and also in book form. Similar evidence was also presented by others at our second Cambridge conference. Investigations at Tel Leilan in Syria by Harvey Weiss showed that the climate around this site suddenly became arid at the end of the early Bronze Age, resulting in its abandonment for several centuries. This also seemed to have happened elsewhere, and a layer of tephra particles indicated a volcanic event. However, some suggested that the prime cause may have been an extraterrestrial impact. Mandelker argued that we encountered the Taurid complex at this time. Marie-Agnes Courty found evidence that a dust layer at Tel Leilan and other sites in the Middle East had resulted from an impact, but no crater has yet been found. In the next millennium came the end of the Middle Bronze Age, the time of Velikovsky's Venus catastrophe, and later the termination of the Mycenaean period, which Velikovsky associated with the Mars catastrophe. It would appear that these were not cataclysmic periods on the scale envisaged by Velikovsky, but natural catastrophes and cultural upheavals nevertheless occurred on both occasions. The latter was characterized by a change to cooler and drier climates in the Mediterranean region, accompanied by large earthquake storms. There were thus a number of occasions in the geologically recent past when environmental crises occurred, but establishing the prime cause or causes is not easy. It's even possible that cause of one or more of them may prove to be something that no one has yet thought of, particularly since recent discoveries in astronomy and physics have brought home the realization of just how little we really know. As to the best way for young researchers to proceed in this context and to conclude this talk, I could do no better than to quote advice given by Velikovsky in a graduate student forum. What I want to impress upon you is that science today, as in the days of Newton, lies before us as a great uncharted ocean, and we have not yet sailed very far from the coast of ignorance. Don't persist in your idea if the facts are against it, but do persist if you see facts gathering on your side. In science, unlike religion, the great revelations lie in the future. The coming generations are the authorities, and the pupil is greater than the master if he has the gift to see things anew. Imagination coupled with skepticism and an ability to wonder. If you possess these, bountiful nature will hand you some of the secrets out of her inexhaustible store. The pleasure you experience discovering truth will repay you for your work. Don't expect other compensations, because it may not come. Yet dare.